I'm Tim. This PCB Sync.
In this video we will go through the official datasheet of Rogers RO4003C item by item to see what DK, DF, TG, TD, CTE, thermal conductivity and water absorption each represent, and how they affect high-frequency PCB design. All the parameters in this episode are based on the test conditions and typical values from the official Rogers datasheet. Let's start with DK. The process dielectric constant of RO4003 is 3.38, with a tolerance of plus or minus 0.05. The test conditions are 10 GHz at 23 degrees Celsius, and the test method is the clamped stripline method. However, the datasheet also explicitly specifies and lists a design dielectric constant of 3.55 TOSU, which was rigorously tested across a broad frequency range of 8 to 40 GHz by utilizing the technical differential phase length method. These two values serve different purposes. The process dielectric constant is mainly used for material specifications and production control, while the design dielectric constant is more suitable for determining transmission line dimensions, electrical length, and electrical simulation. Therefore, in high-frequency design, you can't just use 3.38 for all impedance and phase calculations. Moving on to the next part, we are going to take a closer look at DF. The second item is the dissipation factor, DF, also known as the loss tangent. RO4003C is tested at 10 GHz and 23 degrees Celsius with a typical value of 0.0027. At the same time, a typical value of 0.0021 is given for 2.5 GHz at 23 degrees Celsius. DF is related to dielectric loss. Generally speaking, the lower the DF, the less signal loss there is as it propagates through the dielectric. However, the final insertion loss is not determined solely by DF. It is also affected by factors such as copper foil roughness, copper thickness, trace width, surface treatment, connectors, and manufacturing tolerances. Therefore, in high frequency and millimeter wave designs, you can't just compare a single DF value. You also need to consider the complete stack-up and actual structure. Next are two parameters that are easily confused, TG and TD. The glass transition temperature of RO4003 is greater than 280 degrees Celsius. TG indicates the temperature limit at which the mechanical and thermal properties of the material's resin system begin to change significantly. The typical decomposition temperature of RO4003C is 425 degrees Celsius. TD refers to the temperature at which the material begins to undergo significant decomposition during thermogravimetric analysis. Both TG and TD reflect the heat resistance of the material, but neither of them alone represents the reliability of the PCB during reflow soldering, thermal cycling, or long-term operation. In actual design, it is also necessary to evaluate in combination with CTE, board thickness, copper distribution, hole structure, and processing technology. Moving forward with our discussion, next let's take a detailed look at common table expressions, which are a powerful feature in SQL queries. Mainly this row. The typical value of RO4003C is 11 parts per million per degree Celsius in the X direction, 14 parts per million per degree Celsius in the Y direction, and 46 parts per million per degree Celsius in the Z direction. For PCB reliability, special attention should be paid to the CTE value in the Z-axis, because when the board is heated it expands along the thickness direction, and the degree of expansion of the copper in the plated through holes is different. After repeated reflow soldering and temperature cycling, excessive thermal expansion may increase the risk of via copper fatigue and cracking. Therefore, for multi-layer boards, thick boards, and high-layer millimeter wave via designs, you can't just look at DK and DF, you must also check the CTE in the Z-axis. Next, let's look at the thermal conductivity. The typical thermal conductivity of RO4003 is 0.71 watts per meter Kelvin, measured at a test temperature of 80 degrees Celsius. Thermal conductivity indicates a material's ability to transfer heat. The higher the value, the more favorable it is for heat to spread from local hotspots to other areas. However, the overall heat dissipation capability of a PCB also depends on factors such as the area and thickness of the copper layers, thermal vias, component packaging, metal base plates, and external cooling conditions. Therefore, thermal conductivity is suitable for comparing materials, but it cannot be directly equated to the final temperature rise of the PCB. Next, let's look at water absorption. The typical water absorption rate of RO4003 is 0.06%, tested under the conditions of immersing the sample in water for 48 hours, with a sample thickness of 0.060 inches and water temperature at 50 degrees Celsius. A lower water absorption rate helps reduce the impact of humid environments on dielectric properties and dimensional stability. However, it cannot be simply concluded that a low water absorption rate guarantees that the dielectric constant dk will not drift. In real-world environments, frequency changes are also affected by factors such as material structure, copper foil, solder mask, temperature, packaging, and product density. As for other noteworthy sections, besides the previous items, there are a few more parameters that need to be specifically confirmed. The density of RO4003C is 1.79 grams per cubic centimeter, and the peel strength of the copper is 1.059 per millimeter, which is equivalent to 6 pounds per inch. It is compatible with lead-free processing, but the standard RO4003C itself does not have the UL94V0 flame retardant rating. If the product specification requires V0, then further evaluation of RO4350B, RO4835, or other certified materials is necessary. So, to summarize, dk affects impedance, propagation speed, and electric field strength, while df reflects dielectric loss, but it is not the only source of insertion loss. Tg and Td reflect the material's heat resistance. CTE, especially Z-axis CTE, is closely related to the reliability of plated through holes and temperature cycling. Thermal conductivity affects the material's ability to transfer heat, while water absorption helps us assess the material's stability in humid environments. Once you understand these parameters, you won't just choose a substrate based on a single dk or df value, but will instead make a comprehensive judgment from the perspectives of electrical performance, reliability certification, and processing requirements. If you are using RO4003C to design high-frequency PCBs, PCBS Select can assist you with material recommendations, stack-up evaluation, impedance design, DF review, prototyping, and mass production. Scan the QR code on the screen and upload your Gerber files to start your inquiry. If you found this episode helpful,